One. Okay, so I'm gonna try to walk you through the semaphores in C and how they help with thread synchronizations. This is part of chapter 6. I've put together a little tutorial to help you understand how they work, going from concept to implementation. Again, just the idea of semaphores, you can think of it like a traffic signal for threads. They control access to the shared resource. They make sure that multiple threads don't collide by entering the same critical section at the same time. Again, without synchronization, or specifically semaphores, we run the risk of going into a race condition, and where the outcome depends on which thread gets there first, something we definitely don't want and we should avoid. In the example that I'll walk you guys through, I have multiple threads. They're trying to increment a shared variable, but here's the key. I'm using semaphores to make sure that only 2 threads can try to access the critical section at once. This keeps things running smoothly and avoids any sort of conflict. So before I'm going to dive into anything, I want to go over 2 important libraries that I'm using that help me and the online resources. This is all linked in your project. So the first one is the pthread library, which you're going to use. This is user space code, and this basically tells you all the lovely functions that you can call when you're creating a thread. Remember, the pthread library also includes your mutexes and your read-write locks. And the second library is the semaphore library. This is the specific synchronization implementation that I'll be using for this project. And again, not project, but tutorial. Here are the different functions that are incorporated in this project. Tutorial, not project. It's what you'll use for your projects. But anyways, okay. So if I'm gonna run this example, as you see, I've created 5 different threads. Each thread has its own unique process ID. Now, because we have the 2 threads trying to acquire at the same time, this allows for it. So in our example, we're going to have thread 1 and thread 3 trying to acquire the lock before anybody else. Obviously, because the first thread came in, it was able to acquire the lock. It incremented. Then thread 3 tried to acquire the lock. It was successful. Then it incremented. So it went from 1 to 2. And then you have the second thread trying to acquire, successful, incremented. Thread 4 tried to do the same thing, acquire, successful, increments, all the way up to 5. And then we go through and we actually release. So kind of going backwards, it's a little weird, but it's trying to release the semaphore. So you have process, thread 3, then 2, then 4, then 1, 5. It tries to release before it actually released it. That's why you have 2 threads, 2 and 2. One is trying to, in the process of releasing it, calling that signal, and once it was successful, it informs us as well. So that's the output. Now let's go through the code, and I'm going to just do blocks of code bit by bit. So these are all of your necessary headers. The first one is for input output. The second one, again, it's for thread management. Then this one is for semaphores functions. I'm using this for my sleep function. And then these 2 will be for getting the process ID and things like that. Next, let's define our global variables. So we'll need a semaphore to control access to the critical section. Then this will be our shared variable that threads will increment. Now let's go into the first function that we write. So it's this whole thing. And this function is just incrementing. So here we are going to define the function that will that will take each thread, will try to execute. So here we're trying to acquire the semaphore. So here's the thread. I'm using the pthread underscore self because I'm on a Mac right now. I'm not on a virtual system. So I have to use this in order to be able to actually print out the process ID. It's a little Mac thing, but normally this is the actual function you would use to get that thread ID. So you got the thread, you got the thread ID, then you're trying to acquire the semaphore. Again, this is acquiring it. Then you're incrementing the shared variable. Here's the critical section. So increment that shared variable, which simulates work. And I do that by creating a sleep variable for 1 second to simulate the processing time. And then once I'm done, I'm trying to release the semaphore. I actually go ahead and release it, then I increment the semaphore and it's completely released. I print out the thread ID with the statement that it has been released, so I no longer hold the actual lock. And this is just for incrementing. So you're acquiring the lock, you're incrementing the shared variable, then you're releasing it. Just a bunch of printf statements. Now, if we go through our main, this is where we'll initialize our semaphores. So we initialize the semaphores. We're creating 5 threads. And then we're going to go through a loop. So this loop actually goes through and creates 5 threads. Then we're waiting for these threads to be finished. So it creates each thread. Once it's created, it actually goes and calls the increment. And it comes back and then it waits for all the threads to be completed. So we have another loop. And then it prints out the final variable, the shared variable, and then it's going to destroy the semaphore. You have to destroy because this is a shared resource as well. And you actually ask the OS to give you access to this specific shared resource. So this is a toy example of synchronization, specifically using a semaphore with threading. Again, this is the output.